All right, we're in the helicopter flying handbook. We're in chapter 10, page 9, confined area operations. A confined area is an area where the flight of the helicopter is limited to some direction by terrain or the presence of obstructions, natural or man-made. For example, a clearing in the woods, a city street, a road, a building roof, etc. can each be regarded as a confined area. The helicopter pilot has added responsibilities when conducting operations from a confined area that airplanes pilots do not have. He or she assumes the additional roles of the surveyor, engineer, and manager when selecting an area to conduct operations. While airplane pilots generally operate from known, pre-surveyed, and improved landing areas, helicopter pilots fly into areas never used before for helicopter operations. Generally, takeoffs and landings should be made into the wind to obtain maximum airspeed with minimum ground speed. The pilot should begin with a nearly accurate and altimeter setting as possible to determine the altitude. There are several things to consider when operating in confined areas. One of the most important is maintaining clearance between the rotors and obstacles forming the confined areas. The tail rotor deserves special consideration because some helicopters it is not always visible from the cabin. This not only applies while making the approach, but also while hovering. Another consideration is that wires are especially difficult to see. However, their supporting devices such as poles or towers serve as an indication of their presence and approximate height. If any wind is present, expect some turbulence. All right, so this is what we're going to be looking at here. Figure 10.8. If the wind velocity is 10 knots or greater, expect updrafts on the windward side of the downdrafts and downdrafts on the lee side of obstacles. Plan the approach with these factors in mind, but be ready to alter plans if the wind speed or direction changes. Something else to consider is the availability of forced landing areas during the planned approach. Think about the possibility of flying from one alternate landing area to another throughout the approach while avoiding unfavorable areas. Always leave a way out in case the landing cannot be completed or a go-around is necessary. During the high reconnaissance, the pilot needs to formulate a takeoff plan as well. The height of obstacles needs to be determined. It is not good practice to land in the area and then determine that insufficient power existed apart. Generally, power is required to take off than to land, so the takeoff criteria is most crucial. Fixing the departure azimuth or heading on the compass is a good technique to use. This ensures that the pilot is able to take off over the pre-selected departure path when it is not visible while sitting in the confined area. Approach. A high reconnaissance should be completed before initiating the confined area approach. Start the approach phase using the wind and speed to the best possible advantage. Keep in mind areas suitable for forced landings. It may be necessary to choose a crosswind approach that is over an open area, then one directly into the wind that is over trees. If these conditions exist, consider the possibility of making the initial phase of the approach crosswind over the open area and then turning into the wind for the final portion of the approach. Always operate the helicopter as close to its normal capabilities as possible, taking into consideration the situation at hand. In all confined area operations, with the exception of the pinnacle operations, the angle of descent should be no steeper than necessary to clear any barrier with the tail rotor in the approach path and still land on a selected spot. The angle of climb on the takeoff should be normal or not steeper than necessary to clear any barrier. Clearing a barrier by a few feet and maintaining normal operating RPM with perhaps a reserve of power is better than clearing a barrier by a wide margin but with a dangerously low RPM and no power reserve. Always make the landing to a specific point and not to some general area. This point should be located well forward away from the approach end of the area. The more confined the area is, the more essential it is that the helicopter land precisely at a defined point. Keep this point in sight during the entire final approach. When flying a helicopter near obstacles, always consider the tail rotor. A safe angle of descent over barriers must be established to ensure tail rotor clearance of all obstructions. After coming to a hover, avoid turning the tail rotor into obstructions. So takeoff. Confined area takeoff, right? We're in confined area operations, takeoff. We're on page 10 of 12. A confined area takeoff is considered an altitude over airspeed maneuver where altitude gain is more important to airspeed gain. Before takeoff, take reconnaissance from the ground or cockpit to determine the type of takeoff to be performed, to determine the point from which the takeoff should be initiated to ensure the maximum amount of available area, and finally, how to maneuver the helicopter best from the landing point to the proposed takeoff position. If wind conditions and available area permit, the helicopter should be brought to a hover, turned around, and hovered forward from the landing position to the takeoff position. Under certain conditions, sideward flight to the takeoff position may be preferred, but rearward flight may be necessary, stopping often while moving to check on the location of obstacles relative to the tail rotor. When planning to take off, consider the direction of the wind, obstructions, and forced landing areas. To help fly up and over an obstacle, form an imaginary line from a point on the leading edge of the helicopter to the highest obstacle to be cleared. Fly this line of ascent with enough power to clear the obstacle by the safe distance. After clearing the obstacle, maintain the power setting and accelerate to the normal climb speed. Then reduce power to the normal climb power setting. Common errors. Failure to perform or improper performance of a high or low reconnaissance. Approach angle that is too steep or too shallow for the existing conditions. Failure to maintain proper RPM. Failure to consider emergency landing areas. Failure to select a specific landing spot. Failure to consider how wind and turbulence could affect their approach. Improper takeoff and climb technique for existing conditions. Failure to maintain safe clearance distance from obstructions. All right, so that was page 9 and 10, confined area operations, your approach and your takeoff. All right, so we're going to hold off there. All right, guys, that was chapter 10. See ya.